Okay, so today we're going to talk about, now that we know all about slope of lines, slope of vertical lines, slope of horizontal lines, positive slopes, negative slopes, all of that, now we can actually write the equation of the line. Okay, now there's three different forms. Okay. The first, these last two you're probably more familiar with. One is called the point slope form of the line, and this we will use m is the slope and x1, y1 is any point on the line. So we'll use this when we're given any point on the line. So it'll be the most commonly used one. And then we'll simplify it to this form y equals mx plus b because this is a very helpful. M again is the slope, but our b we can read from here. Now b is not the y-intercept. 0 comma b will be the y-intercept. So this is a very common mistake. So make sure when you write on your flashcards that you write 0 comma b is the y-intercept, because remember y-intercepts are points, so you need an x and a y coordinate. Okay. Now there's this other thing called the standard or general form. Okay. And what that is that we'll have some a times x plus some b times y will be equal to some c. What does this mean? Okay. So the first thing that we should notice in the general or the standard form is that x comes first, y comes second, but both variables are on the left-hand side. Okay. C represents a constant, so does a and b. But what do we want that to be? Okay, well, a is the coefficient on x, and we want it to be positive. Okay. And we don't want any fractions. It needs to be cleared of fractions. Okay. So no fractions. Variables on this side, and then the constant. So put those on your flashcards, and we'll work with it so you can see all of this. Okay, so we'll just jump right in. We're just trying to find the equation of lines. So we have a line that passes through the point 1, negative 3, so this is our x1 and this is our y1, and has a slope of 2. Okay. So we'll use our point slope form, which is y minus y1 is equal to m times x minus x1. Okay. So let's put this in. I'll put our point here as 1, negative 3. Okay, so y1 is negative 3. Notice I'm going to use parentheses, and this is 1. And then we can put in the slope we're given as negative 2. Okay, so this is step 1. It's just, it'll get you points. And now we're going to simplify this, okay? So this becomes y plus 3 is equal to, and now we'll have to distribute this negative 2 through. So negative 2x plus 2. Negative 2 and negative 1 will become plus 2. And now let's solve for y. So I need to subtract 3 from both sides to get y is equal to negative 2x minus 1. Okay. So we've simplified it to the slope-intercept form, which is y equals mx plus b. So our slope here is negative 2, which is good. That's what we started with. Okay. Slope is the coefficient on x, okay? Not the variable x, just the coefficient. Okay. And then our y-intercept, we can read from here, b is negative 1, so the intercept must be 0, comma, negative 1. Okay. Don't forget the 0, comma. Okay. Now, what's nice is if we're given, let's see, here we're given a slope of negative 2/3, but the point that we're given is a y-intercept already, so we don't have to go through this one. We can, but we could just jump to y equals mx plus b, where m in this case is negative 2/3, then the x, and then we'll add b, and b we find from here, so plus 4/3. Now, it would work if we use y minus y1 as well. Okay. why does it work? Well, very simply, y minus, now y1 is 0, is equal to m, which is negative 2/3, wait, this is x, shoot. This is minus 0. This one's 4/3. Sorry about that. Okay. So then we can just simplify it to y minus 4/3 is equal to, well, x minus 0 is just x, and that's being multiplied by 2/3. And now you can just add the 4/3 to both sides to get that. So really, if you just want to memorize one form, this is the form to memorize, and then we'll just always solve it for y. Okay. Now, what was nice about these two is they already gave us the slope and a point. Right? So in this next one, they just give us 2 points. And that's fine. If you're given 2 points, we just have to find slope. Okay? So we'll call this one x1, y1, and this one x2, y2. Okay? So m is equal to y2 minus y1 over x2 minus x1. Okay? The more times you write these out, it's easier to remember. So y2 is negative 1, then we'll subtract from the formula, and then y1 is 2, then negative 2 and minus from the formula 4. So this becomes negative 3 over negative 6, which will reduce to be a positive 1/2. Okay, so let me do this on another page so I don't scramble it. Okay, so now we know 2 points, 4, 2, and negative 2, negative 1, and we know that the slope is 1/2. All right. Now, all we need is the slope and 1 point. Okay. I would pick the easier point. Right? So let's use this one. Okay. So this will be our x1, y1. Right? Then y minus y1 is equal to m times x minus x1. Okay. So we can just start substituting in y minus y1, well that's 2, is equal to m, which is 1/2, times x minus x1, which is 4. Okay. And these x's and y's just stay there. Okay. So now the left-hand side is simplified. We'll just copy that. And on the right-hand side, we'll distribute this through. Okay. To get 1/2 of x, then a positive and a negative will become negative, and 1/2 of 4 is 2. Now if I try and solve for y, I'll add 2 to both sides. So the 2's will go away here. We'll be left with 1/2 of x, but they will also cancel on this side. Okay, now let's do it with this one just so we can see. Let's say our negative 2, negative 1, if we pick that one, x1, y1. Okay. So now y minus y1 is equal to m times x minus x1. Just writing the formula down. Now, in this case, we'll have y minus y1 is a negative 1, so we'll have to use parentheses there. Is equal to 1/2 of x minus x1, which is negative 2. Now we can start simplifying. So y minus a minus 1 is y plus 1 is equal to 1/2 x minus a minus 2 is plus 2. Now this side is simplified. We can distribute this through. So we'll have y plus 1 is equal to 1/2 x. Positive and positive will stay positive, and 1/2 of 2 is 1. Now we're going to solve for y. So we'll subtract 1 from both sides. So we get y is equal to 1/2 of x. So it doesn't matter which way or which point we picked, because they're both on this line, we'll come up with the same equation. Alright, so let's do the next one. It goes through the point -2, -3, and the point -2, -5. I'll give you a moment to start that. So what will we do with this? Well, we'll double check ourselves just to make sure. 5 minus a minus 3, -2 minus a minus 2. This minuses become a plus, and these two minuses become a plus. 5 and 3 are 8. -2 plus 2 is 0. Well, now we find that the slope of the line is undefined. Okay, that's fine. Certain lines do have undefined slopes, so we just have to remember which slope is undefined. So if we think about walking, this would be where it would be impossible to walk on the line. And the lines that are impossible to walk on the line are the vertical lines. Okay, so now it's a vertical line. We have to remember, now is this an x equals line or is this a y equals line? Well, let's do this. Let's plot our points. Okay. So here's the point, there's -2 and then down -3. So here's the point, -2, -3. Okay. That's our first point. Then we have -2, 5. Okay. So here's the point, -2, 5. So this, if we had to draw it, is our vertical line. So now, what has stayed the same here? Was it the x values that stays the same or the y's? It was the x's. So when the x values are the ones that stays the same, this is the line x is equal to -2. Alright. Now let's try this one. Here we have an equation that we're given, and it is in point-slope form. We want to rewrite the equation first in the slope-intercept and then in the standard or general. Okay, we can do that. Alright, so it's y minus 3 is equal to 3/2 of x plus 5. Right. So the left-hand side is already simplified, so we'll simplify this right-hand side. So we'll get y minus 3 is equal to, well, 3/2 times x is just 3/2 x. And then over here, let's see, a positive and a positive will be positives. And then we can just ask ourselves, what's 3/2 times 5? And well, remember we can just put that as 5/1. And if there was canceling to reduce, I would want to do it here. But there isn't, so it's just 15/2. Okay, so now the left and the right are as simple as they can get, but I want to solve for y. So to do that, I need to add 3 to both sides. So y is equal to 3/2 x plus 15/2 plus 3. Okay, but these are like terms, so we want to get those together. And if I'm going to add anything, I need to have a common denominator. So y is equal to 3 halves x plus 15 halves plus 6 halves. So y is equal to 3 halves x. 15 and 6 are 21. 21 halves. Okay, so this is our y equals mx plus b. Now they want us to find the standard or general form, so it's ax plus by is equal to c. Okay. So this is the constants, no variables. We have the x first, and then the y's. We want a to be positive, and no fractions. Okay, so here we go. Let's start by getting, now this is a constant, there's no variable. Okay. This is a term with a variable, so it needs to be on the other side, so let's subtract 3 halves x. So when we do that, and I'd like the x to be first, this rewrites as 3 halves x. Now the y is positive, so it's a plus y is equal to 21 over 2. Okay, I'll let that soak in for a minute. So I subtract the 3 halves x, so the x term goes away, leaving just the constant. Now I have to subtract from both sides. So this would be y minus 3 halves x. But remember, we like to have the a terms first, and that addition commutes, so I could switch this and have it be 3 halves x plus y, okay, because this is positive. All right. Not because this is positive, because y minus 3 halves commutes to negative 3 halves x plus y. Now we want this to be positive, okay, and it's clearly not. But I can multiply both sides by a negative 1. And I'll have to distribute this negative 1 to everything. But that would make my first term to be a positive 3 halves x, and now minus y is equal to negative 21 over 2. Now, what we want is no fractions. Okay? So the way we're going to clear fractions is that we need to multiply by a number that will make the fractions clear. So if I multiplied 2 times 3 halves, okay, I'm just doing a little scratch work over here. Remember, this is like 2 over 1. Then these 2's would cancel, and I'd just be left with 3 over 1, which is equal to 3. Okay. So that, if I could multiply by a 2, would clear this fraction. So let's multiply by 2, but remember, I'm going to have to distribute that 2 to everything, and I'll have to do it on this side as well. Okay. So now 2 times 3 halves is just going to be 3, and the x will stay. 2 times minus y is minus 2y, and now the 2's here will cancel, and we're left with negative 21. So this is in the standard or the general form. Okay, so that'll take a little bit of practice. This is why I'm saying we need to put it on our flashcards so we remember what it is. Okay. Now in the next one, we want to find the horizontal line that passes through this point. So let's draw a sketch of it. If I was at 2, negative 6, I would be in the 4th quadrant, someplace down here. 2, negative 6. Okay. I'm just drawing a sketch. So if I want the equation of the horizontal line, this is the line that will go through it. So now if we were walking on this, this would be a very easy line to walk on, so we know that the slope needs to be equal to 0. If I was to pick another point, I know at the point, this would be the point 0, comma, negative 6. Okay, because I've gone nowhere in the x or y. So this crosses there. I'm sorry, nowhere in the x, only down in the y. And we see the y's are the ones that don't change here, so it's y is equal to negative 6. The horizontal lines are the y equals lines. Now this one gets a little tougher. We're given a point in x1 and a y1. But we want the equation of the line that passes through here and is parallel to the x-axis. Okay, so negative 2, negative 4 would be down here in the third quadrant, so I'm just putting a sketch in. And now, do we want it to go this way or do we want it to go this way? Well, we want it to be parallel to the x-axis. So parallel to the x-axis. Here's the x-axis, so our point needs to be parallel with that. Okay, so parallel with this line through this point. Now, what's the equation of the x-axis? In this line, we saw that it was y equals 6, because this didn't change. So we know this is the point 0, 0. Here's another point, maybe 0, 1. I'm sorry, 1, 0, 2, 0, etc., etc., etc. So this is the line y is equal to 0. Okay? We're not going anywhere in the y direction. Which means the line that we're looking for that is parallel to y equals 0, well, this is y is equal to negative 4. Okay. Now, let's look at the next one. We need to pass through the origin. Remember, the origin is the point 0, 0, and it needs to be perpendicular to the line y equals 5. Okay, so here's the line y equals 5. We would go through this point 0, comma 5. Okay. It's got to pass through the origin. Here's the origin. And I don't want it to be parallel, I want it to be perpendicular. So the line that we are looking for in this case is this line. And in fact, that line is the y-axis. Okay. And so this is the line x is equal to 0. Because this is the point 0, comma 0. Okay. The x's are what has not changed. Okay, so now we have some more conditions. These are kind of fun. We have to think about these. Alright, so the line has to go through this point, so they're giving us an x1 and a y1. And it needs to be parallel to this line. Well, parallel, anytime you're asked about that, that means you need to know the slope. So the slope here is m is equal to 1/2, because we're in y equals mx plus b. So if our line is to be parallel to this line, we need also a 1/2 slope. Okay. And parallel means same slope. So then we can use y minus y1 is equal to m times x minus x1. So y minus y1 is negative 3 is equal to m is 1/2 and x minus x1 is 1. And now we'll just keep doing as we've done. Simplify the left-hand side, so we'll get y plus 3. Simplify the right-hand side by distributing 1/2 of x minus 1/2. And now we'll solve for y. To do that, we need to subtract 3. So y is equal to 1/2 x minus 1/2 minus 3. Now these are like terms, so we need to combine them, and if we're subtracting with fractions, we need a common denominator. So y is equal to 1/2 x minus 1/2 minus 6/2. or that y is equal to 1/2 x minus 7x. So this is a line that passes through the point 1, -3, that is parallel to the line we were given. Maybe we should look at that on Desmos. While I'm getting that ready, why don't you think about, here's our point, and we need to be perpendicular to this line. So think about the slope we need here. I'm going to pull up Desmos so you can see the graph of the line we just found. Okay, let me turn this light off so we can see a little bit better. What did we need? We needed, so we were given this line, 1/2 x minus 3/2. Okay, so this is the line we're given, and now here we have a point. We were given the point 1, -3. Okay, so that just plotted that point 1, -3, and then we say that the equation of the line that will go through this point and be parallel to that is the line 1/2 x, oops, don't put the x there, x. So you notice they have the same slope, so they're parallel, but I need to subtract 7/2, and now it will go through that point that we were looking for. Okay. So that's what we were trying to determine. Okay, so now we are looking at the next one where we need to be perpendicular to a line. So let's do that one as well. Right. In this case, we want it to go through the point -4, -5, and we want to be perpendicular to y is equal to 1/2 x minus 6. Okay. So if we're going to be perpendicular, this means we need to have a negative reciprocal slope. So our line here, m is equal to 1/2. But what we need is the reciprocal, 2/1, and negative. And that's just -2. Okay. Alright, so let's find this point then, or this equation of the line. So y minus y1 is equal to m times x minus x1. Okay. So y minus y1, which is -5, is equal to our m, which is -2, times x minus x1, which is -4. Okay. And now we'll simplify. This becomes y plus 5 is equal to -2 times x plus 4. Okay. Simplifying the negatives. Now we can distribute to get y plus 5 is equal to -2x minus 8. And now solving for y, we'll subtract 5. Y is equal to -2x minus 13. So this is the equation of our line. Now let's put it in Desmos again so we can see what we're talking about. Alright, so we were given, we want to be perpendicular to the line 1/2 x minus 6. Okay. So there's 1/2 x minus 6. We want it to go through the point -4, comma, -5. Okay, so that's that point. And then we say that the line that is perpendicular through that point is, what did we just say that was? Negative 2x plus 13? Negative 2x minus 13, okay, minus 2x, okay, now minus 13. And when we do that, you can see that here they form the right angles, and this line is perpendicular to our first line and goes through that point. Okay, let's do a few more of these, and we'll just keep checking them out with Desmos. It's just Desmos.com. It's a free graphing calculator for you if you want to check that out. Okay, sorry about the color. When I switch back and forth between the screens, it confuses them. Okay, so let me turn this light back on and see if that'll help. Okay, so let's do the next one. So we'll do number 3 and number 4 and then check on Desmos separately. Okay, the point is 2, negative 1, and we need to be parallel to 2x plus 3y is equal to 5. Okay, so we have a little bit more work to do here. This is not in y equals mx plus b, so we can put it that way, and that way we could figure out what the slope of this line is. Okay, so we're going to go for y is equal to mx plus b. That is, we're going to solve this equation for y. So the first thing we need to do is subtract 2 x's from both sides. So we get 3y is equal to 5 minus 2x. Now we'd like to have the mx term first, so let's just rewrite this as 3y is equal to, well, 5 minus 2x is the same thing as negative 2x plus 5, because the 5 is positive. And now we're almost there. We just need to solve for y, so we can divide everything by 3. And then we get y is equal to negative 2/3 x plus 5/3. Okay? So now we need to be parallel to this. So what does it mean to be parallel? We ask about slope. We'll need the same slope. Okay? So the same slope we're going to need is negative 2/3. Okay. Now we can begin. Y minus y1 is equal to m times x minus x1. So y minus y1 is negative 1 is equal to, using the same slope, negative 2/3 x minus x1, which is 2. And now we'll simplify on the left-hand side. So this is y plus 1. Okay. And then we'll simplify on the right-hand side, distribute that negative through. So this is negative 2/3 x. The negative and negative become positive. And then 2/3 times 2, remember that's 2 over 1. There's no canceling that will occur. So this is 4/3. Now we'll just solve for y, so we have to subtract 1. Now I'm going to have to subtract 1 over here. It's okay if we just write minus 3 over 3, because we're just going to have to get a common denominator. So y is equal to negative 2/3 of x, and then 4/3 minus 3/3 is plus 1/3. So this is the equation of the line that is parallel to this line that passes through this point. Okay. We'll check it on Desmos. Let's do the next one. Number 4, we need to go through the origin. Okay, and remember the origin is 0, 0. And we need to be perpendicular to x minus 4y is equal to negative 11. So this is in standard form. When I'm asked about perpendicularity, remember we're looking for slope, but it needs to be negative and the reciprocal. So I need to know the slope of this line. So let's solve for y. Well, let's add 4y to both sides. So we get x is equal to negative 11 plus 4y. The nice thing about doing that is now I have a positive value for y, so I won't have to divide by a negative. Then we'll add 11. So x plus 11 is equal to 4y. And now we want to solve for y, so we'll divide by 4. On this side we'll get y, and then we'll have 11 fourths. And x over 4 is the same thing as 1/4 x. Okay? Because if you multiplied 1/4 times x over 1, when you multiplied them together, you'd get x over 4, and x over 1 is just x. Okay? So this is in y equals mx plus b. Okay? So now we know the slope is 1/4. But what does that mean for what we're looking for? Well, we need the negative and the reciprocal. So the reciprocal, we'll just flip it over as 4 over 1. We make that negative, and that's just negative 4. Okay, so now let's do it. So this is our slope, and this is our point. So y minus y1 is equal to m times x minus x1. It's great we have like zeros. It's going to be nice. So y minus 0 is equal to negative 4 times x minus 0. Well, y minus 0, that's just y. And x minus 0 is just x. And x times negative 4 is just this. So this is the equation that is perpendicular to this line that passes through the origin. Now let's put these in decimals so you can see what's happening there. Okay, so I'll take these off. So our first one, our line was given to us as negative 2 divided by 3 x. Okay, so that's good. It's a negative slope. Right? And then we'll add 5/3 to it. Okay, so that's our line. And the point we were given is 2, negative 1. Okay, so there's our point. And we were supposed to have a parallel line. And we said that parallel line was negative 2/3 x plus 1/3. And there it is, a line that is parallel, that passes through the point to negative 1. Okay, let's try the last one. Okay, so the line we were given is 1/4 x. No, don't put the x there. Make sure it's up top. 1/4 x plus 11/4. Okay, so there's our line. We'll put in the origin, even though we know that where that's at. Okay. Maybe it won't plot it. Okay, well there's the origin. It's got to go through there. And then we said that line was negative 4x. So there it is. This is a line that is perpendicular to the first line and passes through the origin. Okay. So that will get you through your exercises. Just go back and refer to each of these. Remember, we're working on vertical and horizontal lines as well as parallel and perpendicularity. Okay. All right. If you have any questions, send me an email.